One of the main problems of computer science is that there's too much information out there. The amount of information grows exponentially, at least, but our ability to handle information doesn't. And the specific problem I looked at is how do we help users of a social website find information that interests them? Specifically, how can users of ORCID find communities? That's the term that's used for discussion groups. They're like Usenet groups or Yahoo groups. Or how can people find other users who they might want to meet? So I was able to start working with ORCID shortly after it launched. And this shows in the first 10 months, there was exponential growth of members and a lower exponential, but still exponential growth of these communities. Anybody could create them. They weren't very organized. So the question is, how do you help people find communities of interest to them? I wanted to be able to have per community ranked recommendations, where if you were viewing a certain community, you would be told what other communities you might be interested in. And here's an example of some recommendations. Any guesses what community this is for? I see some nods. Anyone want to guess?
Unix programmers.
Okay, not Unix programmers. This is for the geeks community. And the way these similarities were figured was with implicit collaborative filtering. What collaborative filtering means is it was this distributed approach where we look at lots of people's behavior. And it was implicit because we weren't asking people to rate anything explicitly. We were just observing their behavior, specifically which communities they joined. And we worked from the premise that two communities would be similar if they had lots of members in common. So here's some terminology I'll be using. You can consider each community to be a set of members. And we might talk about a base community, B, wine, for wine lovers, and a related community, R, like Linux. You'll see later why I use that. And what we want is a measure of similarity. How similar, how good a recommendation is R for B? And one thing you want to look at is how does the membership between the two groups overlap? There are a lot of people in the wine community who are also in the Linux community. So here's an example. We have the pizza community and two communities I'm not showing the names of with these different overlaps. Which one's the better recommendation?
I would recommend pizza to people after 1 o'clock.
Okay, so someone in the audience said she'd recommend pizza to the people in the upper left group.
Upper right, upper right.
Oh, upper right, excuse me. I was actually asking the reverse question. So if the base community is pizza, should we recommend the one on the right or the one on the left? Yeah?
I'd say the one on the right, because even though it's a smaller group, you have a larger proportion of that group.
Okay, so...
assuming it's a circular group.
Yeah, someone very clever in the audience said he'd recommend the group on the right, because even though it was a smaller overlap, it's a bigger percentage. So the obvious answer, which none of this smart audience did, would have been the one with bigger overlap, which would have been Linux. At the time I did this research, Linux was the most popular community, so it had the biggest overlaps with just about everywhere. I told this to a friend of mine who worked at Amazon, and he said, oh yes, the Harry Potter problem. So whatever book someone looks at, the one most frequently purchased with it is Harry Potter, but it's not very useful to always be recommending that. So group size is also a factor, and I've shown that here as the size of the base and related communities. Also, these relations are asymmetric. For some similarity measures in computer science, it works both ways. A is as similar to B as B is to A. But that's not the case here. So if you look at the Stanford community, the Stanford class of 2006 community isn't a very good recommendation. Let me show you my terminology. The numbers in parentheses are the size of the groups. And what you see here is that there's an overlap of 47 members who belong to both of the communities. So for the Stanford class of 2006, if someone belongs to that group but not the Stanford one, that might be a good recommendation. Or you could argue with me. You could say, no, that's just too obvious. So that starts the question of how do we tell which recommendations are best? So the relationship is possibly asymmetric. I didn't have a very theoretical computer science education, so I walked over to Google Labs and searched, asked actually some UW grads, what formula do I use? The overlap and the size of two groups to figure out similarity. And everybody gave me a different function. And I'll go through these. And what I decided to do, we had some arguments about which ones would be best, but then decided let's implement them all and see. So the simplest one is L1 normalization. You can think of this in terms of vectors, where each member is a dimension, and there's a 1 in that dimension if that user belongs to that community. Or I find it easier to think of it as set notation. Just take the overlap between the two communities and divide it by the product of their sizes. And something to notice about this is this heavily penalizes large communities. If a community is twice as big, it better have twice as big an overlap. Another measure is L2 normalization. In the vector space, this would be the same as the cosine distance. And this is the same as L1, except for the square root sign in the denominator. So you take the overlap and you divide it by the square root of the product. So this penalizes large communities less heavily. Another measure that's used is mutual information. Specifically, I'm looking here at positive correlation, which is the upper left corner in this matrix. What this formula shows is how well membership in the base community predicts membership in the related community. And then there's another version where we add negative correlation in the blue, which is how well does non-membership in the base community predict non-membership in the related community. Some of you will be familiar with Salton's term frequency inverse document frequency measure. And that's used to say that two documents are similar if they have the same words in common. And we can use that, but instead say two communities are similar if they have the same users in common. Another one, this kind of made the most sense to me intuitively, was law of odds, which looks at how much likelier a member of the base community is to belong to R than a non-member of the base community. So switching back to the Harry Potter, how much likelier is a purchaser of The Lion, the Witch, and the Wardrobe to buy Harry Potter than people who haven't bought The Lion, the Witch, and the Wardrobe? That tells you whether to recommend it. This actually yielded the same rankings as L1. So just for fun, we decided to invert it and see what we got. So we use this version. So going into this, we didn't know, would there be significant differences among the measures, or would they all give similar rankings? Which ones would users prefer? Which measure would be best? And would there be a partial or a total ordering of the measures? So here are some recommendations for the I Love Wine community. You can see the I Love Wine community is 2,400 members. And in the upper left corner, we see it overlaps 33 members with ice wine out of 51 members of the ice wine community. And something to notice, remember I said that L1 heavily penalizes large communities? And you see that here because L1 is recommending small communities. L2 is recommending larger ones. That's the one with the square root in the denominator. And then the other algorithms have bigger yet communities. So what's the best recommendation? Saw some people taking wine before, so I know some of you are wine lovers.
Well, it looks like Japanese food.
Okay, so someone said Japanese food.
The red wine, they don't already know about it.
Okay, someone else said red wine if they don't already know about it.
It must be Linux, or you wouldn't have mentioned it.
Professor Lazowska thinks it's Linux. Okay, and there's a lot of different things you could say. You could say the small groups are good because you might not have heard about them. And of course, the only way to find out is to do an empirical test, see which users prefer. So for an experiment, we pre-computed the top 12 recommendations for each of the 6 similarity measures. And then we set up an experiment, the exact details are in the paper, so that when a user views a community page, we do a hash on the community ID and the user ID, and select a pair of measures, maybe L1 and at log odds to compare, and we interleave those, and then we track what does the person click on. And we only looked at new users because we had had other recommendations in the past, and we didn't want those to influence it. Okay, so the next question is how to interpret the results. There were 6 possible cases. On the left, I have somebody's status in the base community. You can be viewing the geeks community even if you're not a member of it. So I divided the member and non-member cases. That's the left column. Across the top, I have their relation to the community they click on. So the big M is for if they were already a member of that community. N is for if they didn't belong to that community and they don't join it after clicking on it. And J is if they didn't belong to it, but they click and join it. So we have 6 possible cases. I have the big M's and little n's to make them easier to tell apart. So which of these measures, which of these squares do we care most about? Okay, I'm hearing J. Member to J? That's what we thought too, that if somebody is the member of a base community, they click on a community they didn't belong to and join it, that's a sign of good recommendation. And it's really unclear how to interpret the other ones. If somebody's a member of a community and they click on something and don't join it, does it mean it was a useful link because they clicked on it? Or was it just a distraction that they clicked on it and it wasn't what they hoped it would be? And you can ask similar questions about each of these squares. So we measure all of those, but we decided the primary feature would be member to join conversion. So we ran this experiment, and we generated 4 million of these recommendation pages, and we got 900,000 clicks on those links. And here I'm featuring the conversion rate. You see if somebody belongs to a community and clicks on a recommendation, there's a 54% chance that they join the community they click on. If they're in a community they don't belong to and they click on a link, there's only a 17% chance that they join it. Overall, it's a 34% chance. So for the analysis, we wanted to take each click, and remember each click was choosing among 2 different algorithms. And if L1 rated that item more highly that the user clicked on, we give a point to L1. If log odds rated it more highly, we give the point to log odds. And doing that, we actually got a total order on our results. So of clicks leading to joins, L2 gave the best results. L1 was next to worst. And all of these were statistically significant except for the single arrow, as opposed to the double arrows.
So these are member or overall?
These are just looking at member of base community joins a community in the top row. Oh, excuse me, clicks leading to join, that's ambiguous. I'd have to check my numbers. If you look at all clicks, L2 wins. The order's the same except that L1 jumps forward. So after this, we were wondering about positional effects. We show things in this sort of grid. Are there positions that people are more likely to click on? Our first experiment couldn't tell us anything about that because we were putting the best recommendations first. So what we did is we generated new recommendations just using L2, and we showed them to different users in different orders. And then we tracked 1.3 million clicks to see where people were more likely to click. So we showed 1, 2, or 3 rows of recommendations. When we showed a single row, anyone want to guess where people were most likely to click? Don't pay too much attention to these pictures because someone else would see a different order. So any guesses?
Center.
It's center?
First.
First? By first, you mean left or right? We have a lot of Iranian users. Presumably. Let's see. Okay, yeah, the center got the most, and the leftmost got next, although this was not statistically significant.
Did you ever test for a size of image?
I did not test for size of image, nor did I separate out the different language speakers. There's all sorts of interesting things that can be done. But since we were doing random orders, the images would cancel out. Okay, what about for 2 rows? And here's another question. What are these the recommendations for?
UW students.
Sorry? Oh, UW students? No?
UW computer science.
There's no computer science.
Actually, Washington State. These are the Washington State recommendations. And what position do you think people are most likely to click on? Again, don't pay too much attention to these pictures.
Bottom center.
I got a guess of bottom center,
Upper right.
upper right, upper left, top center. Okay, the top row got more. The top right actually got the most than the top center. And this was highly significant statistically. Going to 3 rows, this is for fantasy and science fiction book club. Any guesses what people did here, where they clicked most? Okay, someone said middle. Upper. Middle right. Okay, here's what we found. That upper left actually got the most.
Can you go back?
Now again, it doesn't matter what those pictures are. Yeah, so someone theorized when there's so much information, people just stop at the first one, although I can't tell you why, I can just tell you what happened. We got a lot of reactions from users about these related community recommendations. We got hundreds of emails a day. We had something they could click on requesting that we add certain recommendations. And we got a lot of angry emails from the people who created communities. So some were angry because here we were adding something to their community page that they had no control over. And then people were angry about some specific recommendations. There were recommendations of communities that they did not think were similar or tasteful or appropriate. And I sympathized with them. We heard from them about using recommendations. So for the C++ community, we recommend a community for people who don't understand women.
Thank you.
And for chocolate, we recommended PMS. Okay, but not all the recommendations were amusing. I created the She-Nerds group, and see if you can guess which link I didn't like.
Linux chicks.
So it was this one. So I actually implemented the feature to allow a community owner to delete a recommendation. At Google, we do not do things by hand. If a Google community owner is unhappy, she needs to fix it for everybody before she can fix it for her community. So we had a feature where the community owner could remove recommendations and add their own. And evidently, I wasn't the only person. This was the first one that was removed. I wasn't the only person to want this. And just over a week after it was released, 60,000 recommendations were deleted and 260,000 were added. So this was a very popular feature. And an open question is, how do these compare with automatic recommendations? Is this more useful to the users? I mean, it makes the community owners much happier, but is this benefiting the users? In some cases, people deleted communities that they saw as competing with them, that were very similar to them. So that would be interesting to find out. There's many possible future research areas. One idea would be just flipping things around, and instead of determining similar communities based on common users, figuring out similar users based on common communities. And one question would be, is it useful? So for example, there were a total of 9 users who belonged to these 3 communities that I belong to. So how could that be used? It could tell me you might want to meet these people. They share some of your interests. Or someone looking at my page, Orchid is mostly used for dating. Interested in Ellen? Sorry, she's married. Try Jessica. And even though this was based in a social network, I didn't really make use of that information. You can imagine taking into account distances in the social network. We have demographic information. Should we count people from the same country? Should we use that more in recommendations? Should we use it less? What about different ages? And Brazil was and continues to be the most popular country, so you'd often get recommendations for communities in languages you might not speak. So I'd like to acknowledge my co-authors, Mehran Sahami and Orchid B, and the Orchid team, pictured there. It's grown a little bit larger now, but they kept the site running while I got to do this fun experiment. And for more information, I have the paper up here, and I'll be making it available. You can also get it and other papers from labs.google.com/papers. I wrote a kind of silly article about this for Orchid Media. It's referenced in the paper, and the URL is there. I wrote a number of silly columns on Orchid data mining, because we had the data I wanted to test. Are blondes, on Orchid, you can rate how sexy, trusty, cool people are. So we had the data. I wanted to find out scientifically, are blondes sexier? Are gay people more cool? So you can find out my results about that. And also Google is hiring, including at this Kirkland office. They want to expand it a whole lot. So you can find out more about that by talking to any Googler here at google.com/jobs. And I just want to let you know about next week's talk, which Alma Witten will be giving, and that's a week from today. And now I'd be happy to answer any questions. Yes.
So yes, when you were considering the problem of common membership in 2 different sets, or 2 different groups rather, basically 2 users that had common membership in 2 groups would contribute the same no matter what. Did you consider by any chance like giving more points to one that was more active in both groups, for example? And,
That's a very good question. The question was, you treated 2 users belonging to the same 2 groups the same. And did you think about weighting it by which users were more active? That would count as a stronger link toward a stronger recommendation. Something else you could consider is if someone belonged to fewer communities. If there's someone who belongs to 1,000 communities, maybe you should weight each of those connections less than someone who just belongs to 4 communities and participates in all of them. We did not do that. Our hypothesis was we'd be able to get good enough recommendations doing things this way, and I think that was the case, but I think that would be valuable. Yeah?
I want to pull off this back on just a little bit. As a user, from user experience, one of the difficulties of getting recommendations is it takes up a fair amount of real estate and time to review them, and it's potentially useful. But perhaps if there was a pre-filtering ahead of time, so that the user could say, you know, these are the areas I'd like to see recommendations in, instead of just arbitrarily selecting 2 or 9 out of 10,000. Have you ever thought about doing it that way, where the user has a little bit of pre-selection ahead of time?
Okay, so the question was about giving the user more ability to specify what they'd like recommendations about, and that would certainly be a good thing to do. Since this was expensive to compute, we needed to pre-compute everything, and the total number of communities by the total number of communities is already a pretty big number, so we left it at that. Something that would be very, very interesting to do would be to have per user recommendations. In fact, that's something Amazon has. They have these per item recommendations. When you're looking at one book page, you might like this other book, but they also have recommendations personalized for users. And if one of my counterparts at Amazon wanted to give a talk about that, how you compute efficiently, I find that very interesting. I'm not sure I fully addressed your question.
No, I was thinking about instead of having 10,000 with 10,000, you divide those 10,000 user groups into maybe 30, 40 general areas, and so you've got 10. So you have one user group against, you know, a 20th of your total population.
Okay, so the question was about.
You could have technical, you could have consumer, you could have like popular media, you could have like political news discussions.
Okay.
And then so the user can say, well, I really don't care about popular media or music, but I would like to see what other technical recommendations you've got.
Okay, so the question is to be able to group the recommendations by category.
So the user can select which category.
So the user can select what category they're interested in. So they might not be interested in politics, but maybe they're interested in food. Because you can see some of those relations were across lines. You know, someone likes pizza and you recommend Linux. That could be a bad recommendation. Well, one thing we considered was clustering, where we divide things up into groups. And that would be a perfectly good thing to do. Valuable, we just didn't do it. Yes?
I worry a little bit about when you recommend here, you're going to be merging the membership of the groups, and so you won't have the distinct difference of why you want 2 different groups. When they then have all the same set of members, then their conversation is going to tend to be the same, and you've lost some advantage. Do you think about possibly disadvantage to the community from this recommendations?
Okay, the question was, with these recommendations, this will make communities have more similar memberships as each other. So it might reduce diversity, that different communities will become more similar. Well, it'll also there will be a feedback effect with the recommendations. Because if you start by saying these 2 communities are kind of similar because they have some members in common, and then they're both featured on each other's page, they're going to get more and more alike. So that is something that could happen, and it's not something that we measured. In the back?
So if someone was in one of these groups, would they find a very similar group redundant? Why bother generating it, not joining it? They'd rather get like something new, some new type of discussion.
Okay, so the comment was maybe you don't want to recommend something too similar because people should be recommending something different from what they already have access to. And I'd say, and we were measuring empirically, so it could be that similar is the wrong word, that when we made a recommendation that someone clicked through and joined, maybe it's not because it's similar, maybe it's because it's something different. One example would be people who go to the wine community thinking it's about wine is not an emulator, the Linux program. And if they go there for the wrong reason, then they might be happy to see a link to Linux or to Linux wine, which is a subject that isn't similar, but it's what they wanted. So that's hard to measure, but an interesting question. Other question? Oh.
Like the Harry Potter problem is like, you might sell a lot of Harry Potter books, but everybody already knows about Harry Potter, there's no point in telling them. So these smaller groups would be just more interesting to receive that information, whereas these other groups, they're not on the news all the time, so even though it's a big thing, if they overlap, they still might be interested if the numbers are there.
Okay, so the comment is that even though you might sell books by recommending Harry Potter for everything, it's something people know about. It might be more valuable to recommend things they didn't know about. So I'm going to go back to the recommendations. So with this I Love Wine community, where we have the small, quirky communities that you might not know exist, ice wine, Pinot Noir, those are the smaller communities, and what we found empirically was that L1 produced some of the least popular results. But you could imagine wanting to be able to crank it, to be able to ask for small communities or big communities. There's a sort of trade-off between the likelihood that somebody will like something and novelty. Are you going to present something that'll really excite them, that's different from things that they knew about? Paul?
Yeah, so also so this is a somewhat of a tangent, but different communities behave differently at different sizes. So I was just wondering, if you encourage people to go to these smaller communities, it's actually going to change them. And I was wondering if you saw any of that or had any way of measuring that at all.
Okay, so the point was that a community behavior depends on their size. If you start with a small community and you have a lot of people joining it, then that might change the community. And we did have problems with that. We had a user who was very unhappy because her feminist sexuality group, Cliturgy, was listed as a recommendation for a bunch of groups that she didn't think were appropriate, that she thought were merely obscene. And I don't know Google, so I'll put this online. So instead of having her feminist membership, she was having these people from this bigger group with different values from her join the community, and she shut down the community because of that. And when I found out about that, it may have been too late, she may have deleted it, but I talked with her, and that's when I would have manually removed until we could fix it, because it was changing. It was changing the community, it was ruining the community from her point of view. Of course, do we count the creator of the community as being more important than the users who vote with their clicks? Yes?
So you said you added the control for a community owner to control what was recommended to the people viewing their page. This would be an example where the opposite permission, basically, to control where your page is or where your group is recommended to, would be useful.
Okay, so the comment was we allowed community owners to control the recommendations appearing on their page. What about letting them control which pages their community was recommended on? And we did not do that, although it's something that the liturgician would have liked. But that you just have to rely on people emailing community owners that there would be link swaps. So my guess would be that if someone doesn't want to be listed, there's plenty of people who want to be in that position who will be asking for it. Something else we could have done would be let community members make suggestions about what should be related, but we decided to centralize it in the community owner, and users could email them. Yes?
So the fundamental motivator to include this feature in the site, was that to, what was the goal behind that? Why include this feature at all?
Okay, the question was why include this feature at all? What was our goal? And I'd say the goal was to help the users find information of interest to them.
Why?
Why? Because we want them to use the site and to enjoy using it. So right now, people might create a community that's identical to one that already exists. At first, we made it so you could multiple communities with the same name. That was done to prevent a land grab, but I think we decided it wasn't a good decision. But we thought our users would be happier, get more benefit out of the site if they were able to find communities of interest to them. And at that time, there wasn't a good search mechanism. When someone created a community, they put it into one of 29 different categories. But when you have hundreds of thousands and then millions of communities, that's not a good enough hierarchy.
I'd love to know how long this whole process took from after you had got your multiple answers for the different algorithm to use, and once you made a decision to cut and go. How long did this whole process take?
Okay, the question was how long did this process take? It was pretty fast. It was over a period of months. The dates are listed in the paper. This was done during ORCID's first year, 2004. And I was working on other projects, and we had to wait for the people to click. So, swapping in different processes. But ORCID, the team was kind of in startup mode, so we were able to push things quite quickly.
So on that chart, where would you see the effect of this project? Would it show up at which point in that chart? Would this have an effect in, this went out to everybody, right?
Right. The recommendations went out to everyone. The question is, where does it show up in the chart? We did the first experiment in July. And it's not clear to me that that had a significant effect. So I guess I mentioned the possibility that if people could find related communities, they might not create new ones, and the data does not bear that out. Okay.
Size of community, though, might do that.
Okay, comment was that size of community might be affected. Yeah.
So you mentioned you pre-compute the correlation or the recommendations. How often do you do that? How static it is?
Well, for the experiment, we did it once. It would have been too difficult to measure if things were changing. And actually, I'm not responsible for that part of the system anymore, so I can't tell you how often it's done now. But since community owners have been able to do the recommendations, that's sort of been filling that niche. What we implemented was something where we actually generated more recommendations that could fit, and we showed them to the community owner, and they could get rid of some and get more suggestions. And back?
You were talking about how the evidence didn't play out that making the changes, adding the on made a difference in the way that people join and stuff. But you were really new. I mean, how it acts now might be very different than it did when it was first started out. I think you have a lot of creation at the beginning.
Okay, the point was that even if it didn't affect community creation then, it was a very different site than it is years later, and it could be having a different effect now. That's true. And it's just wonderful, all the different things that could be measured. It was great for me to be able to, all these different researchers were claiming that this is the similarity measure you should use, or that one is. So there were a whole bunch of questions I wasn't able to answer, but I was able to do some comparisons. But you're right, there's all sorts more that can be done here, and I'm leaving you with more questions than I'm answering. But as I said, Google's hiring. Yes.
So to evaluate these similarity measures, you exposed your customers to an interleaved set of the different results. Did you give any thought as to whether or not there could be a way to evaluate these offline without actually doing a lengthy user-facing experiment?
Okay, the question was, we used our users to do this evaluation. Is there a way we could have done it offline? Do you mean like with hired evaluators?
Right. Is there a way to evaluate the goodness of a recommendation without?
Okay. Is there a way to evaluate the goodness of a recommendation without subjecting users to this? I think no. I'm not an expert in evaluation, but I think the best measure of what's good for users is seeing what users do, what they click on, and maybe we could have done it for a shorter period of time. I don't know if we needed to do it as long in order to get statistically significant results. But I think doing it as an actual user test with many clicks was valuable here. And I think there was enough benefit to our users to justify it. All of them were getting recommendations, and we were figuring out which measure would give the best recommendations for our users, and then implement that and publish it.
Yeah, I just find it interesting because there's a lot of research on recommender systems that have various metrics of how good their results were that don't involve talking to actual users. So I was curious if what's your opinion as to the actual value of end user interaction versus some of these more academic approaches to evaluating the recommender system?
The question was, for some evaluations of recommender systems, they don't look at what the actual users do. They have some independent evaluation. And I just reviewed a paper and I criticized it for having separate evaluators because the evaluators can't know the intent of the person initiating the query. So I think it skews your results to hire people to do the evaluation. And I've done that, and I had someone giving evaluations for pages that were in a language he didn't speak. But even when the people are competent and trying their hardest, they just can't know what's most relevant. We looked at those, which was better, ice wine or red wine. The only person who can decide that is the actual user. And that's my opinion.
What about an approach like sampling some of the people who actually joined the community based on the recommendations and asking them more sort of qualitative questions about, is this a community that you thought was good, or are you actually participating in this community you joined? Just to kind of get more of that information, because I kind of agree you're privileging just the joining as the measure that says that this is successful, the recommendation is successful. And that's true in a certain sense, but in the long term, is that really useful to that person? Are they just joining lots and lots of groups? Or?
Okay, that was a very good question. It was, should we just be looking at what communities people join? Wouldn't it be better if we could get some qualitative information from them about why they joined it, or see whether they keep using it? And I agree, those things would be valuable. We didn't want to impose on the users, requiring more work for them. And while it would have been interesting to see whether people kept using the communities, the team was busy enough keeping up with the exponential growth and trying to. that we didn't measure it. That would definitely be interesting. And when we looked closer at the data, we did see some interesting effects mentioned in the paper. There were some types of communities that people clicked through to a lot but didn't join. Okay, and I'll give you a hint. If you join a community, its picture gets listed on your page. Okay, so all of the communities with the lowest conversion rate were what's called adult. And none of the communities with the highest conversion rate were. So this was a case where people were clicking through. Maybe they were clicking through to the same community every day. They weren't joining it. So it was a good recommendation, but by just measuring joins, we weren't capturing that. Let's see, how are we doing on time?
You want to take 2 more questions?
Okay. Yes?
Go again. So you, as she was asking about the motivation behind this, and you stated that it was to get people to use the site more, did you find that that was accomplished either by this, like in terms of usage per user? Did that increase after this was done?
Okay. The question was, our goal was to help the users get more benefit from the site or use the site more, and did they in fact use it more? And we couldn't really measure it because, well, I've taught about exponential growth, but I didn't understand it until I worked on ORCID. And it really grew exponentially. The site would work great with 1,000 users, and then we'd get 10,000, and we'd have to fix some bottleneck, and then it would work great until we had 50,000 users. So there was enough problems accessing the site that how many page views users had wasn't under our control. Okay, yes?
Have you considered any factors other than position on the page that affects the click-through rate, and other than just the matching, the union of the two memberships, but as far as just what affects behavior, like as far as the size of the icon or the colors used or anything like that? Did you test anything other than position?
Okay, the question was, did we look at any factors other than position in click-through, like the size of the icon or the colors that were used? We did not do that. We could have done that. Some communities had no picture, and it just says no picture. And I didn't include any on the slides because they're not very interesting to look at. But we didn't break those out separately and see how much likelier someone is to click if there's a picture, if there's a good picture, if there's a big picture, if there's a many-colored. But that's a good question. And not only are there openings at Google, I think there's actually openings on the ORCID team. So.
All right. Well, let's thank